and temperatures involved in their use. The Umiuco hot forging press is a powerful piece of equipment that is capable of exerting immense pressure on heated steel to shape it into the desired form. The billet is heated to a high temperature in a furnace. Once it has reached the desired temperature, it is placed in the press, and the punching tool is brought down onto the center of the billet with immense force. This causes the tool to punch a hole through the center of the billet, creating the opening that will eventually hold the propellant charge. After the hole has been punched, the shell is removed from the press and moved on to the next stages of the production process, which may include trimming, finishing, loading with the propellant charge, and attaching the fusing mechanism. Kovac Center is a renowned company that specializes in the production of high-quality ammunition. They have a well-established ammunition production process that ensures their products meet the highest standards of quality and reliability. The production process begins with the cutting of the raw materials. Kovac Center sources their materials from trusted suppliers. The materials are then cut to the required size and shape using precision cutting machines. The cut materials then move to the forging stage, where they are heated to a high temperature and then hammered into shape. This process ensures that the ammunition is strong, durable, and can withstand the harsh conditions it is subjected to during use. The next stage in the production process is plastic part production. After the forging stage, the ammunition components move to the machining stage. At this stage, the components are further shaped and refined using precision machines. Undergo an external blasting stage. This involves subjecting the components to a high-pressure stream of abrasive material to remove any rough edges and improve their appearance. The next stage is internal blasting, which is done to remove any debris or impurities that may affect the ammunition's performance. This stage involves subjecting the components to a high-pressure stream of abrasive material, which removes any internal residue and prepares the components for the final stage of the process. In the closing process step, the hole in the ammunition casing is indeed closed using a specialized process known as IPS setting. IPS setting is a type of forging process that involves placing the casing between two dies and applying pressure to deform the metal and close the hole. The final stage is heat treatment. This involves subjecting the ammunition to high temperatures to harden the metal and improve its strength. The heat treatment process also helps to relieve any internal stresses that may have developed during the production process. This ensures that the ammunition is reliable and durable and can withstand the rigors of use. This factory is a joint stock company and is a part of the military-industrial complex in the Russian Federation. It has a long history of producing ammunition for various purposes, including military ships, combat guns, tank guns, field artillery, and aviation. During the Great Patriotic War, the factory was one of the main defense enterprises supplying ammunition for the front, and it has continued to develop and produce cutting-edge ammunition technology ever since. The factory's production capabilities include rockets and shots of various calibers for naval aviation and land guns, as well as civilian products associated with mining enterprise. The plant is equipped with high-precision equipment and modern controls, and its experienced staff is constantly searching for possible products for development and able to compete on foreign and domestic markets. The anti-aircraft missile factory in Moscow is believed to be one of the main production sites for the Sa-21 Growler and other air defense systems developed by Russia. The factory produces various components and parts of the missiles, as well as assembling and testing the missiles before they are deployed. The assembly process for the Sa-21 Growler is a complex and precise procedure that involves multiple stages. The first stage involves the production of the missile's components and parts, such as the guidance system, propulsion system, and warhead. These components are manufactured to exacting specifications and tolerances to ensure maximum performance and reliability. Once the components are produced, they are assembled into the missile's canister. The canister is a sealed container that houses the missile during storage and transport, as well as during launch. The canister is designed to protect the missile from environmental factors such as dust, moisture, and temperature changes. The next stage in the assembly process involves the integration of the canister into the launch vehicle. The launch vehicle is a mobile platform that carries up to 4 canisters, each containing a single missile. The launch vehicle is equipped with a hydraulic system that raises the canister into the firing position when the missile is ready to be launched. Before the SA-21 Growler can be deployed, it must undergo rigorous testing to ensure that it meets the system's performance specifications. The testing process involves both laboratory testing and field testing, during which the missile is launched and tracked in real-world conditions. The SA-21 Growler, also known as the S-400 Triumph, is a long-range air defense system developed by Russia's Almaz Central Design Bureau. It is considered one of the most advanced and capable air defense systems in the world, capable of engaging a wide range of targets, including aircraft, drones, cruise missiles, and ballistic missiles. The SA-21 Growler is a mobile system that consists of a command and control vehicle, a surveillance radar vehicle, and up to 12 launch vehicles, each equipped with 4 missiles. The missiles themselves are housed in canisters that are stored on the launch vehicles until they are ready to be fired. One of the main features of the SA-21 Growler is its ability to engage multiple targets simultaneously. The system's radar can track up to 300 targets at a range of up to 600 kilometers and engage up to 36 targets at the same time. This makes it a highly effective defense system against both conventional and unconventional threats. The SA-21 Growler is equipped with 4 types of missiles: the 48N6E3, the 40N6, the 9M96E2, and the 9M96E. The 48N6E3 is the longest-range missile in the system, capable of engaging targets at a range of up to 250 kilometers. The 40N6 has a range of up to 400 kilometers, making it one of the longest-range air defense missiles in existence. The 9M96E2 and 9M96E are medium-range missiles, with ranges of up to 120 kilometers and 40 kilometers, respectively. Ateshi Machinery's blanking and cupping press is a key machine used in the production of 9x19mm ammunition. The blanking and cupping press is used to cut the metal sheets into precise sizes and shapes before they are formed into cups. The double-action cupping press is used to form the cups produced by the blanking and cupping press into their final shape. The machine uses 2 stages of pressure to form the cups, ensuring a consistent and precise cup shape. Polishing is the process of washing and cleaning the brass components of the ammunition to remove any debris, dirt, or oil that may have accumulated during the production process. The TSIC machinery uses advanced cleaning tumblers in the polishing process. The cleaning tumbler is a specialized machine that uses tumbling action to clean and polish the brass components. The machine is filled with a mixture of cleaning media, such as stainless steel pins, water, and cleaning solution. The brass components are then added to the machine, and the tumbling action cleans and polishes them. The 100% inspection unit for ammo cups is a specialized machine that is used to inspect every individual ammo cup produced during the production process. The machine uses advanced imaging technology and precise measurement tools to inspect each cup. The dimensional inspection unit, on the other hand, is designed to ensure that each cartridge case and bullet produced during the production process meets the precise dimensional requirements. In the production of ammunition, the lead wire is a crucial component that is used to make the bullets. Ateshi Machinery uses a fully automated lead wire extrusion plant to produce the high-quality lead wire required in the production of ammunition. The Ateshi lead wire extruder is a specialized machine that is designed to produce high-quality lead wire in a consistent and precise manner. The extruder is fully automated, which means that the entire production process is controlled by a computer system, ensuring accuracy and consistency. The lead wire extruder works by melting lead pellets in a heating chamber, then forcing the molten lead through a die to form the wire. The wire is then cooled and cut to the required length, ready to be used in the bullet production process. The Ateshi lead wire extruder is designed with safety in mind, with various safety features in place to ensure the safety of operators and the machine itself. The The machine is also easy to operate, with a user-friendly interface that allows operators to monitor the production process and make any necessary adjustments. By using the fully automated lead wire extrusion plant, Ateshi Machinery can produce high-quality lead wire with exceptional consistency, ensuring that the bullets produced in their production line meet the highest quality standards. The lead core press works by feeding lead wire into the press, which then forms the wire into the desired shape and weight. The machine's hydraulic system applies pressure to the die set, forming the lead wire into the required shape and weight. Deburring is an essential step to ensure that the cartridge cases and bullets are free of any sharp edges or burrs that could cause malfunctions or accidents. The shot casting machine is an essential component used to produce the lead shots used in the bullet production process. Ateshi Machinery uses a specialized shot casting machine to produce high-quality lead shots with exceptional precision and consistency. The Ateshi shot casting machine is a specialized machine that uses molten lead to produce lead shots. The machine uses a series of molds that are precisely machined to ensure that each lead shot is produced to the exact specifications required. The shot casting process begins by heating lead to a precise temperature, ensuring that the lead is melted and ready for casting. The molten lead is then poured into the molds, and the machine applies pressure to ensure that the lead fills each mold completely. Once the lead has cooled and solidified, the molds are opened, and the lead shots are ejected from the machine. The lead shots are then inspected for quality and consistency before proceeding to the next step in the production line. This process is crucial in ensuring that the bullets are consistent in size, shape, and weight, which is essential for accuracy and performance. After the bullet production, each bullet is inspected for quality, weight, and consistency before proceeding to the next step in the production line. The case press is an essential machine used to produce the cases used to hold the gunpowder and bullet. Ateshi Machinery uses a specialized case press to produce high-quality cases with exceptional precision and consistency. The Ateshi case press is a hydraulic press that uses a series of dies to form the cases from brass or other suitable materials. The machine applies pressure to the dies, forcing the raw material to take the required shape. The case press has a series of dies of different sizes, allowing the production of cases of different calibers and sizes. The machine is designed to work with a range of materials, including brass, copper, steel, and aluminum. The Ateshi case press is designed with safety in mind, with various safety features in place to ensure the safety of operators and the machine itself. The machine is also easy to operate, with a user-friendly interface that allows operators to monitor the production process and make any necessary adjustments. By using the case press, Ateshi Machinery can produce high-quality cases with exceptional precision and consistency, ensuring that the bullets produced in their production line meet the highest quality standards. Case production is the third step in the process. The brass cases that hold the bullet and gunpowder are produced using a similar process to cup production. The machines are designed to produce high volumes of cases quickly and efficiently while ensuring consistency in size, shape, and thickness. Each case is inspected for quality before proceeding to the next stage. The final step in the process is cartridge production. This is where the bullets are loaded into the cases and gunpowder is added. This step requires precision and accuracy to ensure the safety and effectiveness of the final product. Each cartridge is loaded with the correct amount of gunpowder, and the bullet is seated securely in the case. The cartridges are then inspected for quality and consistency before being packaged and shipped to customers. Ateshi Machinery's 9x19mm ammunition production line is a highly efficient and automated process that ensures quality, consistency, and safety in the final product. The company uses advanced technology and machinery to produce high-quality ammunition that meets strict industry standards. Each component of the ammunition is produced with care and attention to detail, ensuring that the final product is reliable, accurate, and effective. In this part, we will visit Mid-South Munitions, a family-owned and operated ammunition manufacturing company located in Clarksville, Tennessee. The cartridges are first fed into a rotating cage with many holes. The cage rotates, and the cartridges pass through the holes and empty into a container. This step is used to sort and transport the cartridges efficiently. The shell of the cartridge follows a rotating spiral to help transport it to the next step in the manufacturing process. The shell then passes through a vibrator. The shell then passes through a press to shape the head of the cartridge. This step is important, as the head of the cartridge needs to be shaped properly to allow for the primer and bullet to be inserted. The cartridges are clamped and pass through a machine with many tubes, which inserts the primer, powder, and bullet into the cartridge. The primer is a small metal cup that contains a tiny amount of explosive material. When struck by the firing pin of a gun, the primer ignites and creates a spark that ignites the gunpowder inside the cartridge, propelling the bullet out of the barrel of the gun. After the primer has been inserted, the next step is to add gunpowder to the cartridge. The machine uses a precise amount of powder to ensure that each cartridge is loaded with the correct amount of gunpowder. The powder is poured into a tube, which then guides it into the cartridge. Once the primer and powder have been added to the cartridge, the next step is to add the bullet. The bullet is the projectile that is fired out of the gun when the cartridge is ignited. The machine uses a tube to guide the bullet into the cartridge and ensure that it is properly seated. The final step in the process is packing the cartridges. This step is done manually. The worker pours the bullets into a device with many holes, and the bullets fall through the hole and are packed. Mid-South Munitions are known for producing ammunition with exceptional accuracy, consistency, and reliability, using top-quality components and state-of-the-art equipment. The company produces a variety of ammunition types, including pistol, rifle, and shotgun ammunition, and they offer a wide range of calibers and loads to meet the needs of different shooting applications.